Hey guys, so in this video I'm going to show us a technique for rewriting a quadratic function in a way that can give us some more information about that quadratic function and in fact help us solve the quadratic function. I'm not going to show us how to solve the quadratic function using this technique today, but I'm going to just show us how we go about rewriting the quadratic function. So the technique is called completing the square. All right, so what we're going to do is we're going to take a quadratic function. I have one here, f of x equals x squared minus 8x plus 5, and we're going to write it in the form a times x minus h all squared plus k. Right, we're going to put it into that form, and then I'm going to talk a little bit about what we can gain from writing it in that form. All right, so how do we go about completing the square of a quadratic function? Well, what we do is the following. We take our function, so I'll rewrite it here, x squared minus 8x, but I'm going to rewrite it in a particular way. I have x squared minus 8x. I'm going to leave a little space and I'm going to write my plus 5 over here, okay? And here's what we do now to complete the square. I'm going to put parentheses here, like so. And to complete the square, what I want to do is I want to look at the coefficient that's on the x term. Here I see that that's negative 8. And what I'm going to do is I'm going to take that coefficient, I'm going to have it, square it, and then add it on. Say that again. I'm going to take the coefficient that's on the x term, in this case that's negative 8, I'm going to have it, in this case that would be, well, negative 8 divided by 2 is negative 4, square it, negative 4 squared is 16, and then add it on. So I'm going to add plus 16, and I'm going to put that right here inside my parentheses. Of course, it seems a little funny that I could just add a 16. Can I really do that? Is that all okay? Doesn't that sort of change my function? Well, yes, it does. And so because I've added 16, I must subtract 16 in order that everything balances out. And where am I going to subtract that 16? I'm going to subtract it right here at the end, minus 16 right here at the end. And essentially, once you've done this, you have now completed the square. And all you have to do at this point is gather up your terms and write it in the form that you want. All right, so what I have to spot is that this x squared minus 8x plus 16 now, inside my parentheses, every time I do this, what you will have actually formed, and what I have formed here, is a perfect square trinomial. And so inside these parentheses, this can be rewritten as x minus 4 all squared. That is, x squared minus 8x plus 16 is really just x minus 4 all squared. And I leave it to you to convince yourself of that. You can take that x minus 4, you can multiply it by another x minus 4, FOIL it out, and you'll see that what you get is x squared minus 8x plus 16. And every time you do this, you will always have that perfect square trinomial inside those parentheses that you'll just have to find for yourself, figure out which one it is that you have. And you're going to write it now in that form. What have I got at the end? Well, I see up on top here I've got plus 5, take away 16, 5 minus 16 is minus 11. And that's it. That is my function, f of x. This is the original function, x squared minus 8x plus 5, but it has been rewritten. It's the exact same function, just rewritten in this form. And we call this completing the square. Sometimes I call it perfect square form. And so I have it, as you see, we wanted it in the form a times x minus h all squared plus k. Well, in this case, my a just happens to be 1. That's what's out in front of that parentheses, if you like, just omitted it. My h, well, what is my h? Well, I notice that my formula, if you like, or the form that I want, has x minus h all squared, and I have an x minus 4. So my h, because I have a negative, because my completed square form has that negative already, my h then is simply 4. My h is simply 4. x minus h all squared plus k. So what's my k? Well, my k is what's there at the end, and in my case, that's negative 11. That happens to be negative 11. Okay, and that's it. You've done it. You've correctly rewritten the quadratic trinomial in this completed square form, and we have identified that h and that k. Excuse me. In the next video, I'm going to show you how we can use this form now then to solve quadratic equations. And we've seen other ways to do it, factoring or in the quadratic formula. Well, this is another way that we can solve quadratic trinomials, or indeed any kind of quadratic function that we like. But just for today, I just want to talk about this h and k. What is this h and k? Well, it turns out that h and k, this 4 and this negative 11, 4, negative 11, happen to be the x and y coordinates, respectively. H is the x coordinate, the k is the y coordinate, of the vertex of your parabola. We know that a quadratic function will make a parabola, and h and k are the vertex of that parabola. If the parabola happens to open upward, it will be, the vertex will be the minimum value of that function. If the parabola opens downward, like so, it's like an N shape, then the vertex will be the maximum value. We know that because this, the leading term of this function is positive, that is, the x squared term is a positive coefficient, that this will open upwards, and so this hk will be a minimum value. That will always be your vertex. So I have graphed it here on Desmos, and so sure enough, there is your function. This is the function x squared minus 8x plus 5, and you see that this right here, 4, negative 11, is indeed your vertex. All right, let me take another problem. I will take x squared. This is my function, f of x squared plus 8x plus 21. So this will be my function now. All right, again, I want to write it in that form, a times x minus h all squared plus k. The way we do this, the way I like to do it, is I rewrite it, x squared plus 8x, then I leave a space, I put in over here like 21, so all I've really added at this point is that space. And what I'm going to do is I'm going to put parentheses here. And now I'm going to look at the coefficient on my x term, in this case that's positive 8. I have it, square it, and add it on. Well, half of 8 is 4, square that, that's 16. I add plus 16 here, and so over here I must subtract 16 so that everything again balances out. Add something, you must take it away later on. All right, so gathering up my terms, I now know that I should have inside my red brackets there, I should have a perfect square trinomial. Just I have to figure out what that is. Well, x squared plus 8x plus 16, that is really just x plus 4 all squared. Again, you can FOIL that out and you can convince yourself that that really is what that is. I have, after my parentheses, I have 21 minus 16. Well, that's going to be positive 5. 21 minus 16 is plus 5, and that's it. My work is done. I'm now in completed square form. My a, my coefficient at the front, is simply 1 again. My h, well, in the form that I want, it's x minus h. Here I have x plus 4. So that x plus 4 can be thought of as x minus negative 4. And so my h is negative 4. Negative 4. And my k, well, that's just whatever number I have tagged on at the end. In this case, that's 5. And like I say, that hk represent the x and y value of your vertex. And so my vertex is really just negative 4, comma 5. Negative 4, comma 5. And you can graph that on your graphing calculator or on Desmos, and you can see that that is indeed your vertex of that given parabola. All right, I'm going to take one more. This time I have f of x, and I have 3x squared minus 12x minus 7. All right, that's my function. All right, something just a little different this time. We notice that I don't have a leading term. The coefficient of my x squared term is not 1. All right, in this case it happens to be 3. So just something we have to do here before we begin is what we have to do is we're going to factor out that 3 out of the first two terms so that I actually have the coefficient of my x squared term is essentially 1. So I'm going to factor out that 3 to begin. So if I factor out 3 out of x squared, well, I'm going to be left with just x squared, of course. If I factor out a 3 out of negative 12, I will be left with negative 4, and so that's negative 4x. So I have 3 on x squared minus 4x, and of course I have this minus 7. So I've rewritten it. I've just factored out the 3 on those first two terms, not the last term. There's no need to factor out of that last term. Just those first two terms is just fine. And now I proceed like I did in the previous problems. I'm going to rewrite this as 3 on x squared minus 4x. I'm going to leave a space, and I'm going to have here minus 7. Okay, let me switch to my red pen when I put in this term that I need here. All right, what is the term I need to put in? Well, I take the coefficient of my x term, that's negative 4. I'm going to have it, square it, and add it on. Half of negative 4 is negative 2. Square negative 2, that's 4. So add that on. I have here plus 4. Now here we need to be careful. You might think that, well, okay, we've added on 4, so now we need to subtract 4. But we need to be careful. There is a 3 in front of these parentheses, and that 3 is also on this 4, this red 4 that we've just added. So really we haven't added plus 4. We've added 3 times plus 4, and so that's 12. So by adding on that plus 4, we've really added 12 to the function overall because of that 3 out in front. And so what we need to do is we need to then subtract 12, not subtract 4. So we need to subtract 12 over here. So we've added on by adding that plus 4, and then multiplying it by that 3 that we factored out. We have essentially added 12 to the function overall, so we must subtract 12 from the end. Okay. So, gathering up, I have a 3 out in front. Inside my parentheses, I should have a perfect square trinomial. Let's see if I can identify what that is. X squared minus 4x plus 4. I think that's going to be x minus 2 squared. X minus 2 squared. Minus 7 minus 12. Minus 7 minus 12 is minus 19. So I have 3 on x minus 2 all squared minus 19, if I am correct, and I think that I am. Okay, I'm in the form that I want. I'm in that form a times x minus h all squared plus k. This time my a wasn't 1, it was 3. I'm not going, that's okay, that's fine. My h and my k can still be identified. My h is, well, it was a times x minus h. Well, my x minus h is x minus 2, and so h is 2. And my k, that's whatever I have here at the end. In this case, that is negative 19. And there you have it. H is 2 and k is negative 19. And like I said, that is the x and y coordinate, respectively, of the vertex. Let me just graph that over here. So I will have 3x squared minus 12x minus 7 and we see indeed here my h was 2, my k was negative 19, and my vertex is indeed 2, negative 19, and that is indeed what you find when you graph these on your graphing utility. You can confirm that for yourself. And so this method of completing the square gives us some information about the quadratic function. In this case, in particular, what we're looking at today is that vertex, which is a very useful thing to be able to find. Next time I'll show you how we can also use this method to then solve those quadratic functions. I would like you to try some problems yourself. So let me give you a couple of problems. I'll give you two. F of x is x squared plus 10x plus 13. There's one. So quadratic. Notice again that's going to open upwards. So write it in that completed square form, and then identify h and k, that vertex. And another one, I'll do this, g of x. Let's take g of x equals 5x squared plus 30x plus 25. Those are the two problems I'd like you to try. So that is completing the square, a very useful technique for quadratic functions. Thanks.